So next we're going to work through a bunch of examples. I think there's going to be 5 of them to get used to integrating in spherical coordinates. And on some of them I'll reference cylindrical coordinates as well, just so we have a way of comparison. Okay, so first example, we want to integrate, normally write e, and then we'll write, we want to integrate this function over the region. And then e is the region that is inside x squared plus y squared plus z squared equals 16, so sphere radius 4, with z greater than or equal to 0. So we're taking the top half of the sphere, the inside of the top half of the sphere. Maybe on this one you don't have to draw a picture, but I think it's good to get into the habit of drawing a picture, because on some problems you will definitely have to draw a picture. Okay, so we've got the top half of the sphere of radius 4. All of these are 4. This top one's 4. Okay, great. Now, we need to convert that to polar coordinates, right? And then we'll have this out here. Okay, so remember that z was rho cosine phi, and that x was rho sine phi cosine theta. And if you don't remember that, you can rederive it the same way we did it the first time. Okay, so we get 10. Maybe I'll move my picture over because I might need a little bit more space. Okay, so I'm going to get 10 rho squared cosine phi sine phi cosine theta plus 3. And then this dv, remember, got multiplied by an ugly thing, or was equal to an ugly thing as well. That's rho squared sine phi d rho d phi d theta. And then in this top half of a sphere, let's see, rho goes from 0 to 4. Phi goes from 0 to pi over 2. We're starting close to the positive z-axis and going only 90 degrees down. We don't go past that. So phi only goes to pi over 2. And then theta goes from 0 to 2 pi. And none of these depend on each other, which means you can switch the order of integration if you want to. Let's try it first without it, and we'll see what happens. Okay, so first we need to actually expand this. 0 to 2 pi, 0 to pi over 2, 0 to 4. I'm going to expand it so I can integrate. So this is 10 rho to the 4 cos phi sine squared phi cos theta plus 3 rho squared sine phi, and that's all d rho, d phi, d theta. Okay, great. Now I can integrate with respect to phi. And I'm glad I kept the 10 inside because this will be rho to the 5. I'll divide by 5, so I get a 2 rho to the 5 cos phi sine squared phi. So these can turn into a lot of writing. 3 rho squared integrates to rho cubed sine phi. Okay, so the numbers were engineered for me. That's nice. I like that. Going from 0 to 4 for rho. There's a lot of variables. Sometimes it helps to write that. You don't have to. D phi d theta. Okay, we're plugging in rho equals 4. These numbers are going to get a little big. 0 to pi over 2. 4 to the 5 is 2 to the 10, which is 1024. So I have 2048. Like the game. I don't know if you guys were around when the game 2048 came out. Plus 4 cubed is 2 to the 6, which is 64 sine phi. Okay, minus, and then we put in 0, we get 0. Okay, now we have to integrate with respect to phi. Okay, so this is a little bit challenging to integrate with respect to phi. I need to integrate this part with a u substitution, and then integrating this part is easy. So if it's a little bit challenging, we can do it, but if it's a little bit challenging and maybe it looks like it'll be easier to integrate with respect to theta first, maybe we'll do that. So what happens if we switch this? Fubini's theorem still applies. Everything we know about multiple integrals still applies. Okay, I get 2048 cosine phi sine squared phi cosine theta plus 64 sine phi, and I'm just going to switch the order of integration, d theta, d phi. Now, okay, this is easy, so let's do that first. You don't always get something for free by doing the easy thing first, but sometimes you do. 2048 cosine phi sine squared phi, integral of cosine theta is sine theta, plus 64 sine phi, integral of, that's a constant, so we get a theta, and then theta goes from 0 to 2 pi, and I'll integrate with respect to phi later. And this is great. We did a really good thing here, because we have a sine theta here, and sine of 2 pi is 0, and sine of 0 is 0. So actually this whole term will drop out, and we'll just be left with, we have to plug in 2 pi and 0 into there. So we get 128 pi sine phi minus 0 d phi. So that's a lot easier than what we were looking at back here. If we had to integrate with respect to phi, this first part was going to be pretty difficult. We integrated with respect to theta first. We got the first part to drop out. So this is fantastic. Now I only have to do one easy integral with respect to phi. This is, I don't know what I'm writing, 128 pi negative cosine phi going from 0 to pi over 2. Cosine of pi over 2 is 0, minus a negative, so that's positive. Cosine of 0 is 1, so I end up with 128 pi. All right, so this could have been asking something like, if that's a density function, what's the mass? Or I think some of the homework has charge density problems, so what's the total charge in this upper hemisphere? And we can calculate that.